Hey guys, Matthew here. In this video I'm going to talk to you about this thing here, the non-manifold edges option in the edge analysis tool, which is one of the other reasons why a boolean might fail on you. So to begin explaining this, I'm going to start in 2D, so we don't need this, to just explain a concept. So in 2D, if I have a curve, and I draw a line like so, right? So on my left side, if I'm heading this way, everything outside is to my left. This is true for most things. So here we go, here's a curve, right? Depending on the way I'm traveling, one of those directions is always outside. That's pretty cool. But what happens if the curve looks like this? So I'm going to make a rectangle, and I'm going to copy it to here, and let's consider what happens in two different senses. So here we have two individual squares meeting at a point. Now I'm going to explode these, and I'm going to delete these lines here. Now I'm going to make sure these lines continue all the way to the other square, like so. And I'm just going to join it all. So, alright, I'm going to apply that same logic, and I'm going to say, okay, if I'm heading this way, along the curve, that my left side is outside. And that's true after I turn the 90 degrees. That center snap is a bit annoying. There we go. But as I go past that point where they intersect, now it's the opposite. Okay, so that's flipped. So if something intersects itself, I might have some problems. And it turns out that you can actually do this. And an object like this is called, well, especially in 3D, is called non-manifold. And something is non-manifold if it actually makes more sense to be made up of smaller objects and not actually connected. So you can connect things when you shouldn't connect things in RHINO. It lets you do whatever you want. It's quite amazing. So there is a difference between, when I get it to work the way I want it to. There we go. There we go. Okay, let me move this one back. Sorry about this. There we go. Cool. Okay, I'll just make a new rectangle. There we go. 10, 10. Cool. So there is a difference between this, where it's made up of two objects, and the one where it's made up with one. And this is a far better way of working than this one. So now in 3D, if I make a box that's 10 by 10 by 10, because that seems to be my favorite proportions of boxes, and I copy it so it shares a singular edge, there we go, and I Boolean union it, it might let me do it. And that's a bit odd, right? Is it really connected? It's infinitely thin here, and if I go to my show edges tool and I put on non-manifold, it'll exhibit it as a non-manifold edge. Let's try to make a box that's 10 by 10 by 10 and join it exactly on its corner. Let's see what happens there. And it says the objects don't intersect, but I'm fairly sure I could find a way to cheat it into thinking that they do, nevertheless. So we have this kind of moment which doesn't make much sense from the sake of the computer, and this can cause you some problems. But if I make a box underneath it, I could Boolean union that, and it's quite clear that this is now a local kind of condition rather than a global condition, nevertheless. And maybe I wanted to simplify this geometry, so there's a great tool for simplifying geometry. So if I, for example, had this and I Boolean union them together, I could use a command called merge all faces, that would simplify the number of faces on that object. And if I do it to this object here, it won't do it pretty awesomely. But I could extract the surfaces that are the problem ones, right? I could just extract these guys, delete them, and then just like loft them back in the way that I was doing with the 2D example. And I could Boolean union all that. Sorry, I could join all that. And now I've got this piece of geometry that doesn't say it has a non-manifold edge, but also doesn't really make that much sense. So if I make a box underneath it now and try and Boolean that onto it, I might get some funky stuff happening. It's going to fail. Sweet. So, it's failing because this bit here doesn't make much sense, and it doesn't know what's inside or outside. So you really want to not produce geometry like this in your file ever, if you can help it. And that's the Boolean tool. That's pretty exciting. We're getting through things quite quickly. So the next module will be about drawing things and turning your model into a drawing and setting up pages and line weights and all that kind of cool stuff. So that's it for this module, and I'll see you in the next video and the next module.